The next topic is about simplifying expressions, but before we can do that we have to know something about the terminology involved. There is in fact a lot of terminology involved with algebra. Like terms, for instance, is one of those. Let's have a look. A literal expression such as negative 3x squared y has one term. It's called a monomial. Just think of monorail. If it's got two terms, it's called a binomial. Now, an expression such that minus 3x squared y in fact has two parts to it. It's got a numerical coefficient, that negative 3, and it's got a literal coefficient. Now, as soon as the literal coefficient is the same in two expressions, you can talk about like terms. And what we can do with like terms is to add and subtract. In fact, that is the golden rule of algebra. Only like terms can be added or subtracted. I've got quite a nice example here why that is. We've got, for instance, dollars to stand D for dollars and C for cents. And if I receive $2 and then $3, in total I've received $5. So we can say $2 plus $3 equals $5. See, we keep that same letter part, but we add those 2 and 3's up to get a 5. Now, if you receive $2 and then 10 cents, you can't do much with it. You have to write it as $2 plus 10 cents. You can't simplify that and make that 20DC or whatever. It is 2D plus 10C. So this leads then to that important rule of algebra about simplifying expressions. Only like terms can be added or subtracted. It will come up on the screen now. I've called it rule 1. And when you add or subtract, what you have to do is you have to keep the same literal coefficient and you have to add or subtract the numerical coefficient. Let's have a look at an example as usual. Easy example first and then a more difficult one. 2D plus 10C plus 3D equals, let's look at problem A. Well, we can of course add the 2D to the 3D to get 5D, but we can't do anything more and we leave that as 10C. In the next problem, 3x minus 5xy minus 2x plus 7xy plus 4. There is a 3x and a minus 2x. I can combine that. I can combine those two there. Can't do anything with the 4. And so the final simplification is x plus 2xy plus 4. When algebraic expressions are multiplied or divided, then you can get a different term. I've got that written down as rule 2. Multiplication or division of algebraic terms produces terms with a different literal coefficient. Let's look straight away at an example of that. I've got 2D times 10C in problem A. Well, I can split up the 2D as 2 times D and to change the D with the 10, because I can always say 3 times 5 is 5 times 3. So multiplication can always be interchanged. Then the answer becomes 20DC. See, I've got a new literal coefficient there out of D multiplied by C. Slightly more difficult problem with division. I can certainly divide the negative 30 by the negative 5 to give me 6. It's an x to the power of 4 divided by an x. That would give me x to the power of 3. And then the answer becomes 6x cubed.